There's two topics in today's lesson. Indirect proofs is not on your exam, and so it is in this lesson, but what I was sort of thinking is on Thursday, after we take the test, I'll just show you like one or two, because I don't think it's bad. Honestly, out of all the proofs that are in your textbook, indirect proofs are probably the one proof that I bet people in the real world do use, yet it's not on your exam. Because they're not mathematical, they're very argumentative. So we're going to skip indirect proofs for right now, so I know that really breaks your heart. But again, I will talk about them later this week. Which means then you're doing inequalities today. So you're going to do like greater than, less than sort of things. Today's lesson is in one triangle. Tomorrow's lesson is in two triangles. So this lesson reminds me of in algebra when you guys had to graph inequalities where you shaded, like dash, solid, and shade. And then you had to put a second one on top of it and you had to see where they overlapped. So that's kind of how these two lessons relate. Both of them are not very long. So just, again, ask me questions as we go. But once you pick up on the concepts, it goes pretty fast. So I would say that there's sort of three parts to today's lesson. So part one, you're supposed to notice this relationship. And I was going to give all of you guys a ruler, but how about I'll just measure them and then you can come up with the property, okay? So I'm going to use centimeters and I'm going to quick measure the sides. I'm going to say this is about 6.1 centimeters. I don't think being off 1 millimeter is going to make a big difference. I'm going to say this is about 4.7. And I'm going to call this one about 3.1. Okay? So I want you to see if you can figure out some type of like pattern. Now, a little hint to you would be to look down at number 2 below. Do you notice how number 2, they give you all the sides, yet the question asks you about the angles, yet no angle is listed on number 2. So go back up to your number 1 that I just put the sides labeled and see if you can come up with a way to relate sides and angles. So I'll give you like 30 seconds, so think about it. Let them think about it. Okay. So in just a second, Sadie, you can tell me. Everybody, if we're putting them in order from smallest to largest, smallest would be my 30, middle, largest. Now I can clearly see the physical numbers, so that wasn't really that hard of a question. But how are you going to use this relationship to help you answer number 2? So what were you thinking, Sadie?
The side that's the longest, the two angles on either sides of it are like the smaller angles.
Okay, so this would be the biggest side.
Yeah.
And so how do you know, though, which one is going to be the smallest angle? You said it's the smaller 2 angles. How do I know which one will be the smallest? So if I look at number 2, I can tell you that this is the biggest, which means that these angles are smaller.
It's because if you go back up to this, you can see that the length with the second smallest has the smaller angle on it.
Okay.
So like I don't even know how to describe it.
Okay. You want to try?
Whatever the angle is facing towards the side. So like the 30 is like pointed towards the smallest one.
Correct. That's the way I do it. Now the way you're getting to it does work, but it gets a little confusing to smallest and middle. What I do is exactly what Ella just said. I take the smallest angle and I go straight across. I take the middle angle, I go straight across. So go down to number 2. They want smallest to biggest. So pick your smallest side and go straight across. That means Q is the smallest angle. Now that doesn't tell us what Q is. Like we don't know if Q is 20 or 50. We just know it's the smallest of the 3. Then take your middle one, so 6.1, and go across. And then take your largest and go across. Now everybody listen. Listen. This concept is used in Geometry B because in Geometry B, they're going to give you this exact same picture, only they will say to you, find how long the middle side is. So one, they're going to expect you know which one is the middle, but then they're going to ask you for, like then they'll come up with the formula. So in this one, they would say find the middle angle. Like what is the degree? And it's actually called the law of sine. So they're going to teach you a formula then that you're going to use to calculate exactly what this angle will be. So you're not going to want to use the formula 3 times for one answer. So you better know which one is the middle, the small, and the big. Okay? All right, take a look up here. If I were to measure these, how about let's throw some letters on here. Let's call it ABC. Can you roughly guess which side is going to be the longest, the middle, and the shortest? Now you might be able to somewhat guess based on just how they look, like this one physically looks the longest. But could I calculate this missing angle using, okay, so add them together and then subtract from 180, which I know in my head is 40. So if I were to get my ruler out and were to measure these, how about Sierra? Which should be my shortest side? So if I quick measure, that's about 3.3-ish. Which would be my second side? Sydney?
Sorry.
Not supposed to have them out. Which would be my second? Take your second largest angle. And then what's the side? Across from it. Go across from 54. That's your middle. Okay? Emma, what's my middle one then? BC. So if I quick measure, it's about 4.1-ish maybe. And then by default, my largest angle, we can already probably tell it's the largest side. Well, it looks like it's about 5.1 or 5.2. But do you see how the angles also match up? So you can put whatever you want in this box. You really can. If I was you.
Are we going to have to measure like what you did up there?
No, I mean, you won't have to measure. The problems on the test look exactly like 2 and 3. So if they give you the side lengths, they will ask about the angles. They always ask about the opposite that's been measured. If you wanted to, you could measure them, but it wouldn't really be beneficial. Okay, so right here. Pick whichever one you want to start with. Probably don't maybe write both. So like, how about we say this? I'll start it. Largest angle. How should I finish that? Largest angle is across from the largest side. This is what Sadie's saying because she's just so close to me I can hear her. Now, could we replace the word largest with the word smallest? I just don't want to rewrite it. Could we reverse angle and side? Like the largest side is across from the largest angle. Could we reverse those two words and it still have the same meaning? All right, so go to number 3. It wants the longest side first. So how about Avery? Give me the longest side.
RT.
Correct. RT. Go ahead and finish it, Avery. What?
And then RS.
RS.
And then ST.
Correct. Done. Do you feel good with that? That's part 1. Remember I said there's 3 parts. Part 1, good. Part 2. Part 2. If they only give you, or how about this, not only, how do you know what 3 numbers make a triangle? Like pick 3 random numbers. Don't make them huge. Don't say like 1 million. But like Ivy, pick 3 random numbers.
4, 7, 8.
Okay? If you were to be given a ruler and said, draw me a triangle, 4, 7, and 8, side, 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 would you be able to draw that triangle? Why? Okay, but what these numbers, like what if she would have said 4, 7, 12? What if she would have said 4, 10, 3? How do you know what numbers then make a triangle, what numbers don't? Do you see the questions down below?
Because you need like 2 small ones, don't you?
But look at these ones down here. Look at this. Here's 2 small ones, and here's a bigger one. So if I gave you a ruler and I said draw it, you got 2 small. Would that form a triangle? Look at this picture right here. Do you see 3 and 3? What's 3 and 3 total? Would it close? If you change this to be 4, let's just say you changed one of them, because nobody said it had to be isosceles, right? This picture just happens to be isosceles. Let's say you changed one of them to be a 4. If you had a 3 and a 4, would it make a triangle? No, because wouldn't the 3 and the 4 close right on top? You'd have like a 3 and a 4, and it would be just like one super solid line, correct? But if we change both of them, correct. See, the smaller 2, actually I like the word sum. I'm going to change this. I like the word sum at the beginning. The sum of the smaller 2. Can it be equal?
No. Well,
So can you have a 3 and a 4 to get 7?
no, but you like said they just be.
Yeah, they would just be like right on top of each other. So the sum of the smaller 2 must be greater. Has to be greater than the third. Now, if you notice, 1, I'm not showing you any of these theorems from the textbook, and 2, I'm not highlighting any of their titles. You don't have any proofs in this, so you don't need to worry about memorizing the titles to use. You just have to know how to apply them, okay? So, if you take a look at number 5, how about Mary? Would these 3 numbers form a triangle? Why? Correct. 9 plus 4 is 13. How about 6, Michael? Michael, would this form a triangle? Why not? Well, you're always going to have one longer than the other. Not always, but most of the time. No. Haley?
8 and 7, or 9 and 8 are add up to 17, not 18.
Correct. You need the smaller 2 to be bigger than this, so I'd say no. How about 7, Sam?
No.
Why? You didn't sound real confident.
I'm gonna be honest, I have no idea.
Okay, what did we just do in the last 2 problems? We added the smaller 2 together. So add the smaller 2 together.
Yeah.
What's 7 plus 5?
12.
12. Is that bigger than this?
No.
No, it'd be equal. So if you tried to draw this, it would be like a 12, then you'd have a 5, and then you'd have a 7. There would be no bend. It would just be a flat line. So we would say, no, this would not make a triangle. Okay? All right. This is part 3. I almost think this is part 2B, because this really stems from the piece above. So everybody is okay with 2. The sum of the smaller 2 has to be greater than the third. You're fine with that? Okay, you ready for the last part? They're only going to give you 2. And they're going to ask you for what is the possible third side. So this is what you have to think of. Let's say you have an 8 and you have a 10. Now we don't know what angle is formed here, so let's say it looks like this. If this is obtuse, wouldn't you agree that this is probably going to be the longest? All right, what if it was acute? Then it would be shorter, wouldn't it? Depending on this angle right here, that will affect our side length, correct? So you know you have 8, you know you have 10, but what's the possible third one? Or possibilities? So like for example, can I have a side length of 1? No, because what's 1 plus 8? Okay, so if I make this a 2, can it be 2?
No. Larger than 2. Could you do like x greater than 2?
Okay, so I heard somebody say 3, but what about 2.4? Could it be 2.4?
Anything greater than 2.
Okay, so x is greater than 2. Okay, so hold on. I like that. So are you telling me that this third side could be like 30? Because 30 is greater than 2.
Well, technically, yes.
But hold on. Don't the smaller 2 have to be greater than the third?
Oh, it has to be less than 18.
Why does it have to be less than 18?
Because 8 and 10 add together.
So it has to also be less than 18. It can't be 18, but it could be 17.9, right?
Yeah.
Okay. How am I supposed to write this?
You could write it like 18 is greater than x greater than 2.
Okay.
That's how I would.
This is fine, which I'm okay with this. Your book, I think because the way they do it in algebra, they always put the lower on the other side. So they go like this. Exactly the same answer. But do you remember the compound inequalities, ands and ors from algebra? Algebra used to write it like this because I think you guys were on number lines in algebra. If you remember having to graph these things where they looked like this. Do you remember graphing those? The algebra book always put the low on the left, okay? So watch for that. Now, there is one more twist. So, are we feeling good so far? Okay, turn your page. It's called the third side postulate. So basically what you're going to do is you're going to subtract them. Now, Sadie, if you want to reverse yours, you can. You're going to subtract and you're going to add. Now, this is the way that the book does it because it's the low on the left. But what Sadie told you, her symbols would be reversed. So she would go like this. Again, it's exactly the same thing. It just depends on which one you want to do first. Okay? Sometimes I try to demonstrate the book just in case if you ever do look at it or you watch one of their videos, then this would kind of match it a little. All right, so let's just practice for a second and then we'll hit the twist. How about Taylor Wilson? Number 9.
Like the first one was like the A minus B would be 8,
Okay,
and then X, and then it'd be 32.
correct. Done. I mean, if you want to put your units on there, you can too. Okay, how about this one? How about, it's Amelia, right? I always want to say Emily, but it's Amelia. How do I do this one? 10. Well, what is the formula here say? X is greater than 0, right? So is it actually 0? No. Now, if you think about this in centimeters, if you had 0.1 centimeter, that would be like this. You have 8, and you have like it would be like the skinniest isosceles triangle that you could potentially draw. But it still would form a triangle, right? So I wanted to show you that yes, you can have a 0 because it's actually greater than 0. And then how do you do your other number? Correct. And then you're done. Okay, here's the twist. And it kind of says it right here. They're giving you an application of where this can be used. It says, when John goes from science class to math, science to math, he usually stops at his locker. So could his locker be like right here? Could he leave science class, go to his locker, and then math class could be down a different hallway? Could he go to from science to his locker and then have to go backwards past science to get to his math? Yes? Or what if he goes from science to locker and then math is way over here? Correct? See, what they're trying to show you is that in real life, it could be a triangle, couldn't it? It could be a triangle. But in real life, does it have to be a triangle? I mean, our school's not 100%. I mean, I guess you could maybe have something in the same hallway. I mean, our hallways are kind of like, a lot of them are like all math together and then science a different one. But depending on how the layout is, or think about if you were on a road and you went to like Meyer and then you had to go to like a gas station, they could all be on the same road. So what you do is you still take your numbers. You see your two numbers? You still do the formula. Subtract. What's 110 minus 90? 20? 110, 90? That's 20. What's 110 plus 90? Okay, but hold on. What happens if they're in a straight line? So From science to locker is 90. From locker to math is 110. So clearly my picture's not very good. Yeah, couldn't it be exactly 200 feet? Or go the other way. Science to locker is 90. Then from locker to math is 110. So couldn't this distance be exactly 20? So what I'm telling you is this, is if you get into the application, if you're in the application, you need to put the little bars underneath. Because in the real world, you don't have to form a straight line, okay? Triangles, you don't need the bars. Questions?